Today we are going to be talking about solving two-step equations, okay? I need you guys to please have out a separate sheet of paper. If you have like a note binder or a notebook that you keep your notes in, I want you guys to get that out so that as I work through these problems, you guys can do the exact same thing, because I'm pretty sure all of your guys' teachers have told you that you must show proper algebraic steps when you solve equations, so that when you guys get to algebra in high school, you guys will be prepared with the more complex equations that they will give you, and they will look for these proper algebraic steps. Okay, so again, please go get a separate sheet of paper and a pencil so that we can work through these problems together, and your guys' notes should look exactly like mine whenever we finish this video. Okay, so pause this video if you don't have your scrap sheet of paper yet, and then go ahead and press play when you're ready. Okay, so when we're solving two-step equations, we are still using inverse operations just like we did with one step. So for example, the inverse operation of addition is subtraction and vice versa, and the inverse operation of multiplication is division and vice versa. Okay? The main thing that you guys need to know with two-step equations, okay, is you are always going to move whatever number is on the same side as the variable that's adding or subtracting. Okay, so you always want to move that number first, because our goal is to get down to the variable equals some number. So we're trying to isolate the variable by itself, which means that all the numbers that are on the same side of the equal sign that's with the variable needs to get moved to the other side, and to do that we are using the inverse operations. But again, you always want to move the number that's adding or subtracting first. Okay, so look at number 1. Notice how x is on the left side of the equal sign, so we need to move the 3 and the 1 over to the other side to get x by itself. Okay, remember though, I always want to move the number that's adding or subtracting first. That's on the same side as x. So if you guys see, adding 1, so that's what I should move first. Okay, so I'm going to draw my line where the equal sign is, and if it's adding 1 and I want to move it over to the other side, the opposite of adding 1 is to subtract 1. So you need to show me that you're subtracting 1 on both sides of your equal sign. So that's why I draw this line through my equal sign, because it really does help students realize, oh, whatever I do to one side, I have to do it to the other side as well. Okay? So your plus 1 minus 1 will cancel because that equals 0. Notice how you're just left with 3x on the left side, so you will just bring that down. Also bring down that equal sign. And then on the right side, 10 minus 1, well, 10 minus 1 is 9, so that's the number that will be on the right side of the equal sign. This should look familiar now. Do you guys see how after we subtracted 1 on both sides, we went from a two-step equation to just a one-step equation? That is the process. So we're going from a two-step to a one-step to the answer. Okay, so if you guys remember with one-step equations, if 3 and x, if we're trying to get x by itself, we need to move the 3 over to the other side, so we have to do that by its inverse operation. Remember, a number shoved up next to a variable means that we're multiplying, so the opposite of multiplying is to divide. And to show that you're dividing, remember that you need to show the fraction bar, because fraction bar means dividing. And whatever you do to one side, you need to do it to the other side. So I'm showing you dividing by 3 on both sides. So 3 divided by 3 is 1, so these will cancel. We're left with x equals, and then 9 divided by 3 gives us 3. Okay? And then don't forget to check your work. So actually check to see if you got the correct answer. So down here where it says CYW, that's check your work. Remember, you're plugging your answer back into the variable, since that's what you just solved for, and rewrite the problem and see if it works out. So if I plug 3 back in for x, I get 3 times 3, because remember 3x is 3 times x. So if x was 3, 3 times 3 plus 1 equals 10. So let's see if it works out. 3 times 3 gave us 9, and then 9 plus 1 does equal 10, so I know I did it correctly. Okay, remember you guys can pause this video at any time to catch up, okay, but I'm going to move on to number 2 now. So number 2, again, we always want to look at the side where our variable is at. So in this case, we're looking at the right side. And you always want to move the number that's adding or subtracting first. So if you guys see, we see a plus 9. So this plus 9 is what we need to move first to get x by itself. Okay? So I'm going to draw my line where my equal sign is at. So if I want to move this 9, it's adding 9. So what's the inverse operation of adding 9? If you said subtracting 9, that is correct. The opposite of adding is subtracting. So you do want to subtract the 9 on both sides of the equal sign. So over here on the right side, your plus 9 minus 9 equals 0. So those are going to cancel. You're just left with x over 4. And then if you were to take 5 minus 9 in your calculator, you would get negative 4. All right, so notice how we are down to a 1 step. So we just have one more step to solve for x. So looking at x in the 4, remember we need to get x by itself, so we need to move this 4 over to the other side. And to do that, we need to do the inverse operation. So right now it's saying that x and 4 are dividing. So what's the opposite of dividing? If you guys said multiplying, that is correct. And remember, we're going to start using that dot for multiplication. And whatever you do to one side, you need to do it to the other side as well. Okay? So this is technically saying 1/4 times 4, that would equal 1. So these 4's cancel. And all that we have left on the right side of the equal sign is x. And then over here on the left side, 4 times negative 4, well, 4 times 4 is 16, and then a positive times a negative is a negative. So our answer should be negative 16. Okay, so let's go ahead and plug that in for x to check our work. And again, just rewrite the problem as they had it, except just plug in negative 16 for x. And let's see if this works out. Okay, so we need to divide first. So negative 16 divided by 4 gives us negative 4. And then negative 4 plus 9 does give us 5. Which means that we did it correctly. Okay, so let's try this next one. So again, we want to get w by itself, so we need to get all the numbers that are on the same side as w over to the other side. And with two-step equations, you always want to move the number that's adding or subtracting first. So notice how the 3 is attached to the w, which means that this 3 is multiplying with the w. So yes, it does say subtracting 3, but the 3 is actually multiplying, and that minus sign actually makes this 3 a negative. So this is pretty much saying plus a negative 3w. So we don't want to move the 3 first. We always want to move the number that's adding or subtracting, which means that it's going to be the number that's not attached with the w. So in this case, we want to move the 4. Okay? So since this 4 is positive, it's technically saying that this is adding of positive 4. So what would be the opposite of adding 4 to move it over to the other side? If you said subtracting 4, that is correct, because the opposite of adding 4 is subtracting 4. Okay, So this plus 4 minus 4 will cancel because that does equal 0. So here's the part that students mess up. A lot of students see this 3w and they're like, oh, okay, so I'm going to bring down the 3w, and then negative 2 minus 4 gives me negative 6. Okay. However, there is one thing that they're missing. They are missing this subtraction sign. Remember, this subtraction sign means it's a negative. So this 3w, when you pull it down, you're now saying that this negative 3 turned into a positive 3, which is not correct. So anytime you guys see that minus sign in front of the 3, and after you cross out these 4s, it now does look like a negative. So you need to bring down that negative or minus sign as well with the 3w. Okay? So then our last step to get w by itself, negative 3 and w are multiplying. So then the opposite of multiplying to get that negative 3 over to the other side is to divide it. So you need to show me dividing by negative 3, dividing by negative 3 on both sides of the equal sign. So that then we're left with w equals, and then negative 6 divided by negative 3 gives you a positive 2. All right, and then remember to check your work. So if I were to plug 2 back in for w and rewrite the problem, I get 4 minus 3 times 2 should equal negative 2. So if I take 3 times 2, that's 6. So then does 4 minus 6 give us negative 2? Yes, it does, so I know I did it correctly. All right, so let's try one more here, and then we'll do a couple other problems. So this one, number 4, same thing. We do need to move the number that's on the same side as x over to the other side, and it has to be the number not attached with the x, which means that it's adding or subtracting. So the first number that we need to move is this 5. Okay. So when I move the 5, since it is a positive 5, this is technically saying that it's adding 5. So if I want to move the 5, the opposite of adding 5 is to subtract it. So our first step is to subtract 5 on both sides of that equal sign. Okay, so then my plus 5 minus 5 cancel. And remember what I just talked about. Do you guys see how after I cross out the 5s, this minus sign does look like a negative now? So when you bring down that x, you also need to bring down that negative sign. So please, please, please don't forget to do that, okay? And then negative 7 minus 5 gives us a negative 12. Now, a lot of students see this and they're like, oh, we got x equals, okay, and they want to stop. However, this does not say x equals. This says negative x equals. So we need to get rid of that negative sign. And here's how we're going to do it, okay? What number could we put in front of this x to make sure that whatever number we plug in, it works out? So like you can't say 0, because if I start plugging in 1 times 0, 0, 2 times 0, 0, so we're not getting the same number every time. So what number could we multiply to make sure our answer is the same as what we plugged in? If you're saying 1, that is correct, because if I plug in 1 times 1 is 1, 2 times 1 is 2, so I'm getting the same answer as what I plugged in. So what I want to do is I want to put in a 1 right here in front of the x so that you guys can see if I'm trying to get x by itself, I need to move this negative 1 over to the other side of the equal sign. And to do that, since the negative 1 and x are multiplying, the opposite of multiplying is to divide. So I need to divide by negative 1 on both sides of my equal sign, so that a negative 1 divided by a negative 1 now becomes a positive, So I have a positive x, or in other words, a positive 1x equals, and then negative 12 divided by negative 1 gives me a positive 12. Okay, so now I can check my work. So plug 12 back in for x and rewrite the problem. So 5 minus 12 equals negative 7. See if that does work. Does 5 minus 12 equal negative 7? You can check it in your calculator, and it will say that it does. Okay, so I want to move down to these bottom 3 questions to finish off our notes. So number 7, again, we're trying to get m by itself. So we need to move the negative 3 and the minus 7 over to the other side. And you always want to move the number that's adding or subtracting first that's not attached to the m. So in this case, we need to move this minus 7. So if it's subtracting 7 and I want to move it over to the other side, what's the opposite of subtracting 7? If you said adding 7, that is correct. So you want to add 7 to both sides. So your minus 7 plus 7 cancel because that equals 0. So we are just left with this negative 3m. Don't forget that negative sign. And then negative 7 plus 7, well, that also equals 0. So I still want to bring down that 0. All right. So our last step to get m by itself is we need to move this negative 3, and to do that we need to do its inverse operation. So since the negative 3 and m are multiplying right now, the opposite of multiplying is to divide. So show my fraction bar, negative 3, fraction bar, negative 3. So I'm showing that I'm dividing by negative 3 on both sides. My negative 3's cancel because that equals 1. So I'm left with m equals, and then 0 divided by negative 3 is just 0. Remember guys, your guys' work needs to look exactly like mine. If your guys' work does not look exactly like mine, you are going to miss several points on our test, okay? Alright, so check your work. So plug 0 back in for m and see if this does work out. And then just rewrite the problem with 0 in for m. So if I were to solve it, negative 3 times 0 is 0. So then if I take 0 minus 7, does that equal negative 7? Yes, it does. All right, next one. So we have 9 minus 4x equals 6. Okay. So once again, we want to get x by itself, so we need to move these numbers on the same side as x over to the other side. And you always want to move the number that's adding or subtracting and it's not attached to the x. So in this case, we want to move the 9. And since it's a positive 9, that means that it's technically adding 9. So the opposite of adding 9 is to subtract it. So your 9's cancel because that equals 0. Remember that minus sign. Do you guys see how after I crossed out the 9's, that minus sign now looks like a negative? So when I bring down that 4x, do not forget to bring down that minus sign so that our 4x now becomes a negative. And then 6 minus 9 equals negative 3. Alright, and then our last step to get x by itself, we need to move this negative 4. So since the negative 4 and the x are multiplying, the opposite of multiplying is to divide. So I do want to divide by negative 4 on both sides. Alright, so my negative 4's cancel. I'm left with x equals, and then negative 3 divided by negative 4. I'm just going to leave it as a fraction. You can change it to a decimal, but I'm just going to leave it as 3/4. But a negative divided by a negative does equal a positive. So our answer would be x equals a positive 3/4. And then if I were to check it, so I'm plugging my 3/4 back in for x and rewriting my problem here. 4 times 3/4 gives me 3. So does 9 minus 3 equal 6? Yes, it does. All right, guys, last question here, and this one might be the most important. Okay, so it's very, very important you guys pay attention here. Okay, so we are trying to get k by itself. Okay, so if I'm trying to get k by itself, I need to move this +4 over to the other side because it's on the same side as k and it's the one that's adding or subtracting. So if I want to move this first, the opposite of adding 4 is to subtract 4. So your +4 minus 4 will cancel. You are left with -3/8 k. And then 10 minus 4 equals 6. All right, so we need to get k by itself. And we have a fraction in front of the k. So how do we move this, okay? Well, we have something that's called the reciprocal that we are going to do to both sides to get rid of that -3/8, okay? Because think of it this way. -3/8 and k are multiplying right now, correct? So the opposite of multiplying would be to divide by -3/8 on both sides. But when I do that, watch what happens. So you guys don't have to write this down. But if I take -3/8 divided by -3/8, do you guys remember when we talked about complex fractions, about what we had to do here? Because can we divide fractions? No, we cannot divide fractions. So what we had to do was multiply by its reciprocal. So we changed division to multiplication. And then we took the reciprocal of -3/8. And remember, the reciprocal is just when we flip-flop the numbers. So the reciprocal of -3/8 is -8/3. So instead of showing the division, since we can't divide fractions, when we are trying to get k by itself and we have a fractional coefficient, instead of saying divided by -3/8 divided by -3/8, we are actually just going to multiply by the reciprocal on both sides, since dividing a fraction is the same thing as multiplying by its reciprocal. So if I want to get k by itself and I have this fraction, I want to multiply by its reciprocal on both sides. So like we just said, the reciprocal of -3/8 is -8/3. And don't forget, whatever you do to one side, you have to do it to the other side. So a number times its reciprocal equals 1. So these cancel and we're left with k equals, and then 6 times -8/3. Well, 6 times 8 is 48, divided by 3 is 16. So a positive times a negative is a negative. So our answer is k equals -16. All right, last step is check your work. So plug -16 back in for k. And then actually check your work. So if I were to take -3/8 times -16, I would get a +6. So does +6 plus 4 equal 10? Yes, it does. Okay, so this is your guys' lesson. So remember, with two-step equations, you are going from a two-step to a one-step to its answer, okay? Don't forget to show your proper algebraic steps by showing steps on both sides of the equal sign. And then when you're solving two-step equations, you always want to move the number that's on the same side of k, that's adding or subtracting first, and it's going to be the number that's not attached with the k, okay? If you do that, then you should be doing everything correctly, okay? So just make sure you let your teacher know if you guys have any questions. And if your teacher has any other videos on your Canvas, on their Canvas page, make sure you guys watch them before doing your homework, okay? Thank you.